Okay, so in my class diagram, object diagram, and then in part of interaction diagrams like sequence diagram and collaboration diagram, right? Those are the diagrams we have already discussed, right? So today we'll discuss about a few other diagrams, right? So here is the activity diagram. So is part of Booch, Jacobson and Rambo methodology or techniques. So these diagrams were not there, okay, and this is possibly based on the event diagram of Odell. So here is the new concept that is called as activity diagram. Okay, so here through this diagram we try to represent some processing activities, okay, and their sequence of activations. So they may not be correspond to methods, so they can be overally the different activities that are part of a particular system. Okay. So what is the activity? Activity is just state with an internal action and one or many outgoing transitions which automatically follow the termination of internal activity. Okay, so this is what exactly a activity. So usually it is a state with an internal action. Okay, and from which there will be some outgoing transitions. Okay, and those outgoing transitions automatically follow the termination of the internal activity. Okay, so here we try to represent many parallel activities, as well as we try to we can represent the synchronization aspects involved in these different activities. Like in case of your procedural flowchart, the normal flowchart that you try to represent your algorithm, right? So they actually do not tell you that what are the different parallel activities and what are the whether these activities they synchronize each other. So those things will not be part of any simple flowchart. Okay, that is what the difference. Okay, difference here is it is also some kind of flowchart. It looks like a flowchart, right? But here it represents parallel activities as well as the synchronization aspects. That is what the difference. Okay, so here the parallel activities are represented by some swim lanes. Okay, you understand, swim lanes means in a swimming pool. So what do you do? There are certain lines. Okay, so where the swimmers they swim through that particular lane. So similarly here also you will have certainly swim lanes. Okay, so enable to group of activities based on who is performing them, right? So a swimmer exactly, so he performs certain activities, right? While swimming through that particular lane in a swimming pool. So similarly here also, like a particular component, okay, and that particular component is going to carry certain group of activities within a particular lane. Okay, so here the example here is academic departments versus hostel. Okay, so we will see this activity diagram through an academic process. Okay, then you will be able to understand, right? So the activities in a swim lanes can be assigned to some model elements, example classes or some component. Okay, so as I told you, so in a particular swim lane, certainly few number of group of activities are carried out, and those activities can be assigned to either classes or some component. Okay, usually these activity diagrams are normally employed in business process modeling. So for business process modeling, so usually activity diagrams were usually used, okay, in the industry. So now we are also going to use this in our software developments. That is what we are saying. So carried out during initial stage of requirement analysis specification. Through these activity diagrams, so we will be able to able to do these sort of diagrams at the very initial stage of requirement analysis specification. why you try to carry out this activity diagram, why you try to identify these different parallel activities, because we try to understand the complex processing activities that are involving certainly certain roles played by many components. Okay, we wanted to understand who are the different components going to carry out certain activities, and what such large complex processings are involved. So that is what we wanted to know, we wanted to understand, we wanted to make it comprehend. Okay, we wanted to comprehend the complex problem, right? So can be used to develop interaction diagrams. Now, so once if you have developed an activity diagram, then you can easily develop an interaction diagram by going through these activity diagrams. So this means it is going to help you in developing the interaction diagram. So we have already discussed about the interaction diagrams in the last lecture, right? Sequence diagram, collaboration diagram. So those can be developed once if you have identified what are the different complex processings are involved, right? Activities are involved, then it will be better, easier for us to develop interaction diagrams. That is what we are saying. Now, here is an example of a activity diagram, right? So you can understand this is, we try to, draw a activity diagram for student admission process at maybe NIT Rourkela. Okay. So what are different components that you have? So there is a one academic section, and there is a section, there is a hostel office, there is a hospital, there is a department. So now these are the various components that you have. Okay. Now what we do, we start with the initial stage. Okay, where during your academic section, so first a student go and verify, after, when you are going to take your admission in this institute. So what you do, first you going to the academic section, right? There whatever the credentials the student has, those things will be verified here. Okay, whether you have obtained your 12th, whether you have obtained your gate score or not. So these are the sort of things, right? Or maybe you will be submitting some other card, whether you are the person or not who is going to take this admission, right? So these sort of things, right? So every student records will be first checked out here. Okay, and then what will happen? Then you will be going to the account section. After that activity is complete, then you will be going to account section, right? So there the account section ensures that they receive the fees from that particular student who is going to take admission here at the NIT Rourkela, right? So now once you have paid your fees and those fees are received by the account section, now what will happen? Then now you can be allowed to go into hostel office. You can go to hostel office, or you can go to hospital, or you can go to department, right? So this is what the synchronization is maintained here in this case, right? So you can go into a hostel office and you carry out certain activity parallelly. Now you are going to a hospital, you carry these are the activities parallelly, right? And you can go to a department also, and you can carry out these things parallel. That means so once your payment has been received by the institute, now you are allowed to get a allotment, hostel allotment. Okay, and whatever the fees required for the hostel allotment, so that is also you paid, right? And then accordingly you getting a room. The same time you can go to your hospital, right? So you can give your medical checkup, right? Then you get a conduct medical examination, right? And then that document you need to create, right? And at the same time you need to register all whatever the courses that you are going to take in this particular semester. So these are the all activities parallelly you are carrying out, right? But now within a particular swim lane, now the hostel office, it is considered as one swim lane, right? Within this swim lane, now you can see, so these are the activities, group of activities. Okay, so like allot hostel, receive fees, allot a room. So these are the certain group of activities being carried out within a hostel office, right? So this is the way that you understand, right? Now you have registered all the courses and you obtained your medical examination and you got a room, and thereafter what will happen? Now you will be going and getting your identity card from the academic office. Okay, so now and that is what exactly a student's admission procedure at NIT Rourkela also. Okay, so this is the way that also we do, right? Now this is the way that you will be identifying different activities, and now through this particular diagram you can say you can see what are the different parallel activities are being carried out, as well as you can see there is a synchronization and maintained. Synchronization means what? So you see, unless or until you have registered your courses, unless or until you got your medical examination and you get your you got your room, right? So you are not allowed to get a identity card. Okay, that means after completion of these all three activities, okay, they are going to, I mean, they are following to a termination. I told you, right? So it all starts with a particular activity, okay, and that activity, I mean, it is a state with some internal activity, right? And thereafter, it is from that particular activity there are some. Here you see fee account section. So you have how many outgoing links? Here you have three outgoing links. Okay, one is going to hostel office, one is going to hospital, the other one is going to department. So you will be having three different outgoing links, and now when you go through those all activities, so ultimately you will be followed no, you will be following to you will be directed to the ultimately termination. The termination here is, so you getting a identity card at the end. Okay, so this way that you can draw your activity diagram, right? So here the academic section accounts, these are the various components. Okay, or the you can say you can have certain classes also. You can say each of them may be a class later on, you can say. Okay, and these are all different activities or can be considered as the responsibilities, and these will be assigned to the classes. That is what we are saying. Any doubts of our students regarding this activity diagram?
No, sir.
Okay. You see, unless or until you keep me asking, I may not be knowing. Okay, so when you ask me, then only I may try to explain these things in a different way sometimes. Okay, maybe I'll try to. Okay, but if you don't ask and if you think that you understand everything, and if something is left in your mind, some confusion, and that will lead to further confusion throughout your life. Okay, so this is the right things clear. Okay, don't get them, so you ask me, you very feel free to ask me. Sometimes I may not be able to answer your question, maybe sometimes the question may be, you have different perspective in your mind, so you may be going to ask. So if I don't understand, I will say, if I cannot answer you at this point of time, maybe I'll try, I'll go through different books and I'll try to understand them, and then I will get you and deliver you, right? But if you have doubts and you are not asking, then it's a problem with you. Okay, not with me. This is what I'm clear. I'm always asking you. So but still you should interrupt me, otherwise and sometimes also the more questions that you ask, okay, so I also little feel ki you people are getting many things. Okay, otherwise it looks like very monotonic, and I'm sitting in front of a computer. uh, so feel very boring because I feel like it is only going one way direction, right? So it's not happen also sometimes in the lectures.
Sir, hello
Anyway,
sir.
yes,
Left
yes,
hand side start state and end state, sir. The two
yes,
dots
yes.
in.
So yes, that is that circle. You understand, like in your flowchart also you start with something like this, right? In the
Yes, sir.
flowchart, right? Here is also doing this, but how it is different from the flowchart? So it is different from the flowchart that here you will be able to see that how different parallel activities being carried out, as well as the synchronization things. These sort of things you will not see in your flowchart. Now you visualize. Okay, you go and check a flowchart of your program. Okay, any program, then you will be able to understand how it is little different. Okay, so it is also like a flowchart. So it is start with something and it is terminate, going to terminate that particular state. activity. Okay, the activity will be terminated with some termination, right? Anyway, so now we will be going into the state chart diagram. This is another diagram. It is actually based on the work of David 1990s. So here we try to model the state of an object, because the so these objects, they're going to change their state over time, because I told you some objects will be created, some object will be destroyed, so they keep changing their states, right? So throughout this execution of your software, right? So it is simply a, it is actually based on the finite state machine, where you see that, okay, so there is a machine, it is going to change the state, right? So you have seen like finite automata, right? In your finite state machine, or the finite automata sometimes we call, right, in theory of computation, right, where you see that after taking some input, input symbol, it is going to another state. That means a event, there is an object, so it is going to make changes. That means that machine is going to change its state. Similarly here is also, right? So the state chart, that is the reason why it is also named as state chart diagram. So here we try to model how these, whenever how these objects are they changing the state. That is what we are capturing. Okay, we try to capture the state of an object changes. So your state chart avoids problem state explosion as in finite state machines, right? So because they're in as part of finite state machine, so you know that if the number of states increases to a larger number, so quite it is difficult to handle, right? But here in this case, our state chart diagram usually avoid this, because we can make it as a very hierarchical one, right? We try to see a only particular use case, or you can think of, right, for which you can create a state chart diagram, right? So I mean, for particular use case, how these different objects are being interacting with each other, right? Those things can be done separately. As a result, that can be little avoided. Okay, the state explosion can be avoided. So hierarchical model of a system represents a composite state. So you can have also nested states here. Okay, you can display that also, right? So now these states are so there are certain elements of state chart diagram. One is that initial state, that will be a field circle, and there is a final state, field circle inside a larger circle. Okay, so is similar to the during the activity diagram, we also use this initial state and final state, right? So the state rectangle with rounded corners here, the each and every state will be represented through rectangle with rounded corners. Okay, and there are some arrows. Okay, so that is going to represent the transitions. Okay, between these states, and you can have always Boolean conditions. Okay, guard conditions. Now here is something like this. Okay, so now we try to give a state chart diagram for an order object. Let's say you can think of, you have ordered something, right? Some you have given some order, right? The maybe as part of any Amazon, or any online website, which is handling e-commerce sites like Amazon, Flipkart, where you try to give order, right, for certain number of items, right? So you can think of like, so here order can be one object, right? So we try to represent the state of that particular object. Okay, so you may have 10 objects. If you as part of your software, let's say if you have 10 objects are involved, so in that case you will be drawing the state chart diagram for those 10 objects, right? Here we take only an example order object, right? So now it all starts with the initial state, right? And then so here is a rectangle. Now you can see that it is a state at this particular point of time, right? So the order is unprocessed order. That means yet this order is not processed. Okay, and then what will happen? So it can take two transitions, right? One is that maybe the order, whatever the unprocessed order can change its state. That means it can become accepted order, right? Once the order is accepted, right? So maybe for this, so there may be some condition, okay? So whether it should be accepted, okay? You can, as I told you, if it is accepted, so you can represent by a boolean variable also, or you can have some conditions, right? So as part of within the square brackets, right? So that means here, so some condition is met, as a result this is accepted, right? And then it is accepted, right? Now the order, this unprocessed order state is changed to accepted order. Now after the order is accepted, what will happen? So there can be two things, okay? So maybe the order is fulfilled. That means, after the accept is order, so you have been delivered the items, okay? You have been delivered the items. That means, it can fulfill your order, right? And it cannot fulfill, sometimes it cannot fulfill your order also, because then it can be going to a pending order state, okay? So that means the state will be changed to a pending order. Because why? Some of these items are not available, okay? So in that case, so it will be going to a pending order, okay? And then what will happen? Once the items are available, then it can fulfill again the order. That is the reason why there is a state change from pending order to fulfilled order. That means, so the order is kept for waiting for certain amount of time, because items are not available as of now. So once the items are available, so then the order will be fulfilled, okay? So now this is the way. Ultimately, once the order is fulfilled, then you are going to a termination, right? And if some and at the very beginning, from the unprocessed order, right? So because some of these conditions are not met, okay? So then it can also gets rejected. The order cannot be taken up, right? In that case also, the order will be cancelled. So now it is also going to a termination. This is the way that now the order object can be represented by using a state chart diagram, okay? Is it clear as of now, students?
Yes, sir.
Okay.
Hello, sir.
Yes.
Sir, can we have parallel activities within a single entity like in activity diagram?
uh, No, actually, whenever you have some object, right? So mostly you will be, that object is only carrying out, only one such activity at a time, right? So that is what exactly, as of now, what you are doing. So here what we are saying is how a particular object is changing its state, okay? Whether it is doing that activity or not doing that activity. So that way, it is a state. I mean, we are representing only the state, but actions are there, and you are saying that whether a object can have parallel activities or not, right? So that can be possible in real life, okay? But as of now, what I understand is, so the objects carry certain activities, right? So I mean, they do sequentially, right? Within a, you see, so if you have a particular class, okay, you create an instance, okay? When you create an instance, now you can always call only one method at a time. Have you seen ever in your program that you will be able to call different methods at the same time? No, because your compiler will be going and executing one by one activity. Have you seen?
No, sir. Sir,
Yes. So,
threading
but
is done, but we can't
uh,
predict the result. So
what?
threading is not multi-threading is done, but we can't predict.
Right, right. So threading is there, right? Threading is there. So that is what exactly you try to go through some. So yes, so there are lightweight processes are also there. Yeah. So still it's a kind of yeah. So as of now, maybe through this state chart diagram you will not be able to represent that synchronization. Okay, so maybe at the higher versions of state chart diagram maybe contain that also. Okay, so you can check out if it is. Okay. So is it clear?
Yes, sir. Actually, I was asking about the activity diagram.
No, when you are talking about activity diagram, so these are the different components. Okay, here we are not talking about the objects, right? Yeah. So here is one, you can see hostel office is one component. Okay, account section is one component. Here what I said you is, so usually we try to find out different activities, large processings what are there. So we are talking about that. We are not talking about the objects here. Okay, so only object state of I mean object states are only discussed through this state chart diagram. So that is different and this is different. So what I am trying to say, if you once have this activity diagram, then you can easily draw the interaction diagrams also. That means as I told you before, right? So you can capture the behavior of the object, right? So that means do you understand? Now as part of state chart diagram, we try to only record the state changes. Okay. And here is part of your activity diagram. So you can see there are certainly parallel activities going on. I mean, similarly, your hostel also you carry out certainly, like while you getting a allotment in a hostel, you also create your hospital records also, right? So I mean these are the various parallel activities are going on. Okay, that is possible. Is it clear?
Yes, sir.
Right. So now we will talk about something called software design and patterns. So almost we have we have talked about object oriented software design, function oriented software design we have talked about, right? So now we'll talk a little bit about this design and design patterns, okay, in object oriented software, right? So objects are identified by examining nouns in a problem description. So as before also I told you, right, how you can identify different use cases. So by underlining the verbs, and how you can identify different entities. So just by examining different nouns that are coming within a problem description, right? So many object-oriented techniques are proposed, like you have analysis and design techniques are proposed, right, by Grady, Butch and all, right? So what is the object-oriented analysis? So it all refers to developing an initial model of software product from analysis of its requirement specification, right? So when you are going through any object-oriented analysis, so you try to develop an initial model, okay, so of the software product or the software from its requirement analysis, okay, or specification. From that you trying to create some model, right? When you are going through object oriented analysis, you trying to come up with some sort of model, okay, a initial model. From requirement specification, initial model is developed, okay, that is what. So going through the SRS document, you create a model, right, software model. And analysis model is refined into a design model. Once you obtain that analysis model or the initial model is developed, now that is further refined into design. Okay, so we have seen that, right? In case of function oriented design, what we have seen? So you first, from by going through the SRS document, you have tried to identify and you have drawn the data flow diagram. And once you have drawn the data flow diagram, then you converted that into a design model. What is that design model? Can anyone tell me? What is that design model we have created? By converting
Structure
that,
chart.
yes. So from your DFD data flow diagram, so you have identified the large processings, and then you try to convert those DFDs into a structure chart. Similarly, here also we'll be going through different from the requirement specifications. So then you will come up with some initial models, okay, and then those models will be converted into a refined design model, okay. Right. So this design model is implemented using object-oriented concepts. Now, once you get obtain this design model, like there the structure chart, okay. So once those structure chart is obtained, thereafter you will be going through a detailed design whereby each and every module will be specified, right? What sort of algorithm, what sort of data structure required, and all, right? Then one can directly implement using some programming language, right? So now here object oriented concepts will be used. Here the object oriented programming language will be used to implement your design model, right? So similarly, right? So now there is a unified process, okay? So it's part of this. So unified process is a software development process, okay? UML, which uses UML, Unified Modeling Language, okay, which uses UML to create some models, okay, to create some models. So here it is in a framework. So it is in a extensible framework, right? And which needs to be customized for specific type of project. So I mean it is a larger framework, okay, which actually you can customize according to the type of project that you are going to develop. So that means it provides lot many models. I mean a language through which you can construct different models. Okay, so that is what we are trying to do. Okay, so and this unified process has certain characteristics. Okay, so it has a use case driven characteristic, like so I mean it is all use case driven, right? So you will be seeing that what are the different use cases, I mean what are the different ways a user is going to interact with the system, right? So you start with you taking this, I mean you need to take into account the use cases first. Okay, so that is what exactly the use case driven, and then it is architecture centric. Okay, because so no single model is sufficient to cover all aspects of a system, right? So through a single model, so you cannot cover up all aspects of the system, right? So that is the reason why I talked to you about UML, right? We have talked about various views. Okay, we have seen that users view, behavioral view, structural view, right? So you have seen different views, right? So the unified process supports multiple architecture models and views. That means for different views, so and you have multiple architectural models. That is what we have discussed, right, so far. So now, and also it has a characteristic of iterative and incremental. That means it is going through different iterations, okay, and after each and every iterations, so I mean the development goes through different iterations, right? And from each and every iterations you see an increment product, okay. So now usually, so as part of unified process, there are four phases. Okay, one is inception, and there is a elaboration, and there is a construction, and then the final one is a deployment. So the deployment type, right? So now usually it has four different phases, right? Is part of your iteration. So you will not have the inception phase, because the inception phase is the very initial phase where we try to define the project scope and all, right? So and thereafter you have a what other the elaboration and construction, and then the final one is a transition. So these are the three phases will be part of any iteration. So and if it is a very large project, sometimes your inception can also be part of the iteration. Okay, so that means inception, collaboration, elaboration, and then construction and termination, right? So these all activities, right? So sorry, transition, these are all four different things can be part of a iteration, or Mostly those three, because elaboration, construction, transition will be part of the iteration, and you have very beginning the inception phase. This is what we are saying. Okay. So now then, what is exactly inception? So here we try to define the scope of the project. Maybe you come up with some prototypes, right? So here you try to come up with an approximate vision of the system. What is the vision of that particular system? Okay. And what is the you try to make the business case. That means I mean, what is that it is going to solve your business problem, right? So and then you also be coming up with some rough estimates for cost and schedule, right? So that means it is before your requirement specification exactly we carried out. So that is what part of inception phase. Okay. Now, as part of elaboration phase, what will happen? Usually, you try the functional and non-functional requirements. That means it is during the specification. I mean, requirement analysis and gathering. Okay, so here you try to find out the functional and non-functional requirement. That is what you will be elaborating here. Okay, through this particular phase, elaboration phase. Okay. And your construction phase actually consists of analysis, design, and implementation, right? So you will be carrying out the analysis models, right? You will be coming up with all those models. You will be constructing those models, and then you will be accordingly convert that analysis models into the design models, right? Into the design, and thereafter, those designs will be implemented. Okay. And those implementations will be usually through different iterations. I told you, so as part of a particular, you will have analysis, design, and implementation, right? And each and every iteration releases some features of the system. Okay, is what it is going to release a executable release of the software. Okay, and during your transition phase, usually the product will be installed, or the product is installed in the user's environment, and it is then thereafter maintained. Okay, if any maintenance is required. Okay, so that is what exactly the four particular phases. So it is a completely framework. Okay, and this framework can be refined or to suit a particular type of project. Okay. Now usually, so it has these all different what you say the steps that will be carried out as part of this software design process, object oriented software process. So you basically start when you try to take up any project. So first we start with the SRS document, right? And then also you carry out certain prototypes. That is what I told you, right? So that is just to demonstrate the user interfaces parts. I mean, you try to identify the risk involved in the GUI part, right? So that is the reason why you always start with some GUI prototype, right? And along with you have the SRS document, right? Once you have this prototype, GUI prototypes, okay, you constructed the GUI prototypes and you have discussed the user interface issues, right? And you have the SRS document ready, then you can have a use case diagram. Okay. So that means from the prototypes, so that is what I told you. So it's a use case driven. Okay, it is a use case driven. That means first you will be coming up with the use cases, right? So that means that those use cases can be developed either by going through the GUI prototypes as well as you taking the SRS document, and after that going through these two things you will be coming up with a use case diagram. So where you will find different use cases, right? Now at the same time, once if you can have the use case diagram and your SRS is ready, then also you can create a domain model. That means you can always you have the use case and you have the SRS document, then you can come up with a domain model. That means it is a conceptual model where you will be trying to see something like ER diagram and diagrams, right? That means you will be going to find out what are the different entities that are involved and how these entities are related to each other. So that is what exactly we try to model here. Okay. So now once you have a domain model,
Sir,
yes, yes.
sir, what are the UML diagrams that we can include in the SRS?
No, SRS, you see, I think as part of SRS, so we will be talking like, so these are the UML diagrams. Maybe we'll be going to use, but actually, so it is analysis as part of analysis. Okay, so it is not part of your SRS document, UML diagram. So we will be specifying there. You will be specifying that these UML diagrams may be use some one or two. Because customer, you see, they cannot they cannot understand these all things, right? If you say many states are diagram and all, this is all for the developers, because they are the one who are going to develop the code, right, ultimately. So use, I told you, so as part of SRS, so we keep only simple terminologies. We don't even try to put all computer jargons, right? So maybe you can have a data flow diagram, or because that is what a customer can easily understand, some diagrams, right? So you can also play some diagrams, but maybe you can have this use case diagram as part of SRS, but it's not really required all of the UML diagrams. Okay, is it clear?
Yes, sir.
So now, once you have the use case diagram and you have the SRS, you know these are the use cases and this is the SRS document, and then you can easily identify what are the different entities and how these entities are related to each other. Maybe you going through some conceptual model, right? So maybe the database kind of entity relationship diagrams you can go through, right? And you can come up with the domain model, right? Once you have obtained the domain model, right? So, and you have the use case diagram, you can always come up with the interaction diagrams. Okay, because you understand these are the objects, right? And this is the use case. So you can carry out any interaction diagram for each and every use case, as well as taking into the different entities, right? Or what are the objects that are involved as part of that particular use case, right? So as a result, you can always draw. Once you have carried out your interaction diagram, you can always come up with a class diagram, because here the domain model, right, where it all says these are the entities, right? Similarly, by seeing these entities as well as you have the interaction diagram, then you can always have the class diagram, right? So once you have the class diagram, you have designed the class diagrams, right, and their interactions also identified, those the relationship between those classes are identified, then you can always directly code those classes. That means you can implement those classes using some programming language. So here is the programming language is object oriented programming language, right? So this is the way that we try to convert into a piece of code. Okay, so after going through the design process, is it clear so far, students?
Sir,
Yes.
hello.
Yes,
Sir,
yes.
just now, yes, sir. Sir, just now you told SRS is not to include all the use case diagrams. Then, sir, where are the all use case diagrams are to be used?
So you see, I told you it is all about the analysis phase. Okay. So it is all about it is not the, first you will be getting the SRS document, right? So where, all of these things are being done. Okay. I mean, requirements are gathered. You have created the SRS document, right? Hmm. And what you will be doing there is, so as part of the SRS document, you will be just mentioning out, like you will be giving index. So we have developed the UML diagram, use case diagram, you have developed the activity diagram and all those things, right? You will be mentioning, right? And you will have certain other documents where you will have all of these diagrams, right? Now what will happen? So when this SRS document is given to a designer, right? The designer will go and look into those diagrams only, okay? But basically the SRS document, so what I'm saying, SRS document, so usually it is meant for mostly for the, at the very beginning it is for customer, okay? And when it is going to the designer, so designer will look into those aspects like the customer viewpoint aspects as well as these things, right? So you will be saying, like as I told you, So as part of your SRS, when you do write then the part of model, right? So you will be during the analysis you will be writing these. These are all the diagrams you will have, and you will be part of the diagrams. Okay, do understand what I'm trying to say? And you giving an reference, right? In this many number of pages, page number 20 or 30. So all the diagrams are mentioned, right? Now based upon the kind of user going through that particular SRS document, he will be referring that particular diagrams, but every diagram will be part of SRS. Okay, so but mostly what we do is as part of SRS we try to identify the functions, non-functional requirements, those are things, right? Understand?
Yes, sir.
Okay. So you have all these things, like you have once you obtain the class diagram and all, then that can be converted into the code, piece of code. Okay. So now your use case model. So as I told you, right. So where you try to in a group certain number of use cases, and then you try to pack them into a single package, right? So when you are trying to do this packaging of these use cases, so you need to always you will always see there is a strong correlation between the GUI prototype that you have, okay, and then the SRS document, and then the use case model of the system. Okay, so you will find this use case, so whatever the use cases that you will have, so that will you will find some sort of correlations, right? Let's say you can think of something like that. So there is a in your website, so there may be there is a submit button, okay, or there may be a radio button. You understand? So now, so maybe that radio button, and you have a SRS manual, okay. So and then I mean when you give this submit button, so after entering some data into the text area or the labels, okay, through which you will try to provide your data, and thereafter you will be submitting, right? So now that means that may be belonging to a particular use case, okay. So this is the way that you will be identifying. So you have a GUI prototype and you have a use case model, right? As well as the instructions, the contents related to the use case, right? So they will have a strong correlation. Okay, so that is the way that you will be identifying them, right? So like maybe you have a GUI prototype, which is something that's our prototype is talking about some other use case, okay, then that cannot be correlated, right? So each of the menu options in the top level menu of the GUI would usually correspond to a package in the use case diagram. So if you, that is what I try to say, right? So how you try to find out the correlation between the GUI prototype and you have the use cases, right? So what you try to do is, let's say you have a menu option, okay? So as part of GUI, so there is a menu option, right? So when you click on that, when you take your mouse onto that menu options, when you click on that, what will happen? There are certain menus will be coming, right? Now what I'm saying here is that there is a top level menu. That means the menu, let's say for example you going through your word processor, okay. So when you going through your word processor, what happens? So there you can always have something like this. Let's say for example, if you're going through the word processor, right? So I can see something like this. So there is a file, okay, there is a home, there is a insert, right? So when I click on to insert, okay, so I can see there are many items, right? So I can see there is a table, there is a picture, there is a clip art, there is a shapes, there is a smart art, chart bar, hyperlinks, book, there are many things, okay. So now that means, so you are the insert, the insert or home or page layout, so these are all what, so one use cases you can think of, right? So and now part of this insert there are certain things, right? So whatever the other menu items that you are seeing, so they will be, if you represent each menu item as one sub use case, then that will be grouped into the use case insert. Okay, is it clear?
Yes, sir.
Yes, sir.
Hmm. Right. So that is the way that you can think of, right? But as per the suggestions, it also says that you should not always be, very too tightly tied to the GUI and use cases, right? You should not say also, so for a push button or a radio button, you should not define a use case. Okay. So you define one use case for maybe sometimes you will use push button, sometimes you will use radio button, right? So the designer may change during the development. They can come up instead of push button, they may go for a radio button also, right? So this can change. This can this can change over time. Okay, that's not the issue. But thing is that, so you should always talking about very in general. Okay, menu items, right? So each and every menu item you can say ki, one sub use case of that particular top level menu. So we make certain mistakes during this use case model development. So the first thing is we always try to keep large number of use cases at the top level of the use case diagram. That means as part of your use case diagram, as I told you, let's say if you are going through a Microsoft Word processor, in that case, what will happen? So you will have a top level. Top level use cases means maybe the file, the other one is home, that is the insert, right? So they have use case. So if you have many top level use cases, so then that means sometimes it creates confusion. That means there may be chances that you will have many top cases. They have some sort of overlapping activities. Okay, they will have some sort of overlapping activities, right? So you need to identify the high level use cases. That is what we try. So when I ask you to develop the use cases for a particular project, so whatever that comes to your mind, you will keep them as a separate use case. Okay, so that is not okay. You should always identify the very high level use cases, and these use cases should be very much different, and they must be independent from each other. That is what we try to say. They should be independent from each other, right? So mostly we make mistake, like we try to keep many number of use cases at the top level, so that actually sometimes it also creates confusion, right? So too detailed also, that also leads to confusion, like let's say for example, as I told you, some sub steps of a particular use case will be kept as a separate use case. So the sub steps can be they should be part of that particular use case, so that cannot be a separate use case. Let's say one example here, print receipt be a sub step of withdraw cash use case. Let's say you have a withdraw cash use case. So after withdrawing your money, right? So you will always go for a print receipt, right? Whether the amount of money has been successfully withdrawn from your account or not, right? So now if you say printing a receipt, if you say that it is a separate use case, if you make that, probably it is too detailed, but sometimes it creates confusion. Okay. So that print receipt is a sub-step of withdrawal cash. Okay, so you need to identify that way. So what is that important use case that you need to identify? Omitting test descriptions. So sometimes you try to do not give description to each and every use cases. As a result, it will create much of difficulty in understanding the use cases. I mean, by seeing its use case name, maybe you will not be able to always generalize what are different activities will be part of that particular use case, right? So that also creates confusion sometimes, right? So that means you should always give the name of the use cases in such a way that, so people everybody should understand, whoever going through this use case diagram, so everybody should be able to understand them easily. Okay, overlooking some alternate scenarios. I told you the alternative scenarios also will be there, because whenever I say there is a use case, so a particular use case will be associated with the, there are multiple alternate scenarios are also associated with that particular use case. Like I told you one use case, like withdrawing a money, but with that, so maybe invalid PIN code. So then what will happen? The scenario, right? If you wanted to withdraw money, so you have inserted the ATM pin, but you have inserted a wrong ATM pin. So what will happen? So you will not be able to draw the money, but you will be no, you will be taken to you will be taking some other alternative path. Okay, so maybe you will be asked to re-enter again the money. Okay, let's say for example you have entered the amount of money that you wanted to withdraw, but sufficient amount is not there in your account. So in that case also you will not be taken into. So that means a simple use case can be tied together many alternative scenarios, right? So that is what we try to say. So you try to forget some of these alternate scenarios and you putting them as a separate use case. So probably it also leads to confusion. These are the various basic some of these mistakes that we make always during this. Okay. So now, so there is something called as domain modeling. So as part of the diagram we have seen, right? So domain modeling, right? So it is a conceptual modeling. I told you before also, right? So here you try to identify what are the different concepts or the objects that will be appearing as part of your problem domain, right? So and then also it is going to capture the relationship among those objects. Like one example is a conceptual modeling is a entity relationship diagram, ER diagram that you tried in your database, right? So you try to find out different entities, objects, right? And then so and also you trying to find out whether they hold a binary relationship or they hold a ternary relationship or they hold a partial whether the entity is a weak entity or a partial entity, or whether they maintain the self-referential structure, right? So that means the same entity may be going to relate to the same entity in some way, right? So these sort of things that we try to represent. So that is what exactly we are saying as a domain modeling, right? Only classes, but not methods and data are represented. So as part of here, the domain modeling, we try to identify the classes. When you have the entities, so usually you will have a right. So here we do not try to put the methods and data. Okay, only what do we say? So these are the various classes that will be involved, right? And right. So and we try to classify these objects. We try to whatever the objects that will be that are identified, we classify them into three types. Okay, one is a boundary object, the other one is an entity object, and then other one is a controller objects. Okay, so boundary objects are the one which are very much related to the user interface or the GUI. Okay, let's say as I told you, so as part of your Java or the C++, like you see, so there is a J button. Okay, J button means what? Java button, J level in Java programming language. So that is one class. That means you create one object like push button. So it is also an object there, right? So now this is the object related to your boundary. Okay, I mean it is all related to the interface, graphical user interface. Now these are the sort of objects are called as boundary objects, like J level objects. Okay, or menu. Okay, uh, J menu, these sort of things, the objects that will be create that can be considered as the boundary objects. Entity objects are the ones actually the physical entities that are there. Okay, the physical entities means which are related to I mean you see like as part of your system. Let's say I say so I as a user, right? So myself as a user of the system, so I will be one physical entity right there because I'm going to interact with. So these sort of objects, whatever the objects that you will be representing, okay. Um, the physical entities, those will be called as entity objects. And there are controller objects also, objects that are entirely conceptual. Okay, so these are the objects exactly, they doing certain number of processings. Okay, they will be carrying out certain number of processings actually. So well, a part of that particular object, so they carry out certain processings. Okay, so they are the heart of the software, right? So these are the objects. So we'll talk about all of them individually. So maybe in the next lecture. So the next lecture is scheduled at what time today?
Yes, sir, 3:15.
3:15. Okay, right. So I will continue there that time. Now I stop the lecture. Any doubts so far?